Okay guys, this is video 3-7. See your checklist for when you should aim to watch it by. And the example is find the locations of all horizontal and vertical tangents to, it should say to, the curve that is given right here. Okay, so a horizontal tangent, so you'll have the slope of the tangent line is equal to 0. And for vertical tangents, you'll have that the slope of the tangent line is undefined. All right, so that's what we're looking for. And so the slope of the tangent line is the same as dy dx. All right, so we're going to have to find the derivative of y with respect to x. That's dy dx. It's the same as y prime. So since y is not solved for, I need to use implicit differentiation on everything. So I go d dx of x squared plus d dx y to the third minus d dx 3y equals d dx 4. So I haven't taken the derivatives yet. I'm just setting it up. So I'm just writing down that I'm going to take the derivative of all of these with respect to x. With respect to x means that x is the independent variable. So everything is a function of x, where x would be the input variable. All right, so derivative of this is 2x times the derivative of the inside is dx dx, so chain rule. Derivative of the outside times derivative of the inside, plus 3y squared dy dx minus derivative of 3y is 3 times dy dx equals the derivative of a constant is always 0. So when you do implicit differentiation, after this step, you look for any dx dx, and you could just make that a 1. And then I'll change my dy dx's to y primes just because it makes it easier for me, but you don't have to do it that way. It's a little bit less writing. And then I gotta get y prime by itself because I'm looking for where the derivative is 0 for the horizontal tangent and undefined for the vertical tangent. So in the slope of the tangent line is the derivative, okay? So by getting y prime by itself, I will have the slope of the tangent line, or an equation that will give me the slope of the tangent line at any point that I want. So I'm going to subtract 2x from both sides, and at the same time, I'm going to factor out, let me not do that. I'll go slower. You could do this in one step if you want. Okay, and then I factor out y prime. 3y squared, right? Minus 3. I think I'm doing this right. Yeah. Okay. And then, okay, equals negative 2x. Okay, and then this is y prime equals negative 2x divided by 3y squared minus 3. I thought I was making a mistake. All right, so this is y prime. So this is the slope of the tangent line. So you could be like, or the slope of the tangent line equals this. Or you can even be like, or dy dx equals this. Okay, all of these notations are fine. All right, anything that you want to use. So, okay, so for horizontal, for the horizontal tangent, we need the point where the slope of the tangent line equals 0. All right, that's what we need. So we've got to take the slope of the tangent line, which is this, set it equal to 0. Well, guys, if a fraction is equal to 0, a fraction can only be 0 if its numerator is 0. So I just take the numerator, set it equal to 0, and then I get that x is equal to 0. So I know that the point on the graph of this curve where the tangent line is horizontal or has a slope of 0 is going to have this x coordinate. Now I need to find the y coordinate. All right. So I take the original function, which is okay, so we know x squared plus y to the third minus 3y equals 4. So if x equals 0, then we have 0 squared plus y to the third minus 3 times 0. No, 3 times y equals 4. Okay, so then we get y to the third minus 3y equals 4. All right, so you can try to set this equal to 0. So you can try to go y to the third minus 3y minus 4 equals 0, but that's not a quadratic, so it's not like you can factor it and solve. So what you actually have to do, and this is going to happen a lot in AP Calc, you will need to use your calculator to find the solution to that. So I get my calculator out and I graph this. All right, I can only use x's for graphing. So I go, even though the variable is y, I'm on my paper. So minus 3 times 4. Okay, and then I graph it. Okay, so I'm looking for this right here, this coordinate right here is where this equals 0. So that's what I'm looking for. And the way that you find it is this. You go to second trace, which is calc. You go to 0. And then it will say left bound. All right. So if I exaggerated this curve, it would be like, this, like it's increasing. So left bound of the 0 is going to be like on this side. So it would be below the x-axis. So left bound in this case is below the x-axis. And then they'll ask for right bound, which will be above the x-axis. And then you hit enter and you get this. Now anytime in AP Calc that you've got a round, they're never going to tell you how to round. They're not going to be like round to the nearest tenth. You just have to know that you need to round to at least 4 decimal places. So I'll go 2.1958. So for the y coordinate. So y equals 2.1958. All right. So I'll just go over here and I'll say, therefore, horizontal tangent at 0, 2.1958. Okay. Now I need the vertical tangent. Okay, so for vertical tangent, we need the point where the slope of the tangent line is undefined. All right, so we need negative 2x over 3y squared minus 3 to be undefined. Well, a fraction is undefined. A fraction is 0 if its numerator is 0. A fraction is undefined if its denominator is 0. So I go 3y squared minus 3 equals 0. That's the denominator. Then you could factor this. You factor out a 3 and you get y squared minus 1 equals 0. And then you keep factoring, so you get, that's a difference of 2 squares. So y plus 1, y minus 1 equals 0. So we're going to have two y coordinates here. So we get y equals negative 1, y equals positive 1. And then I'm just sort of like repeating this step here. So we know, okay, so I'll just be like this. I'll say if y equals negative 1, then we've got, so I'm going to plug in negative 1 into the original equation. So we've got x squared plus negative 1 to the third minus 3 times negative 1 equals 4. Oh boy, am I going to get 2? That's crazy. Okay, so we'll get x squared minus 1 plus 3 equals 4. So this is x squared plus 2 equals 4. Oh boy. So you're going to end up, I'm just trying to save room, you're going to end up with x squared equaling 2. So x is plus or minus the square root of 2. Oh my gosh. So for this y coordinate of negative 1, we're going to have these two x coordinates. So we're going to have 2 points. I'm totally running out of room. So I have to, all right. Okay, so I'll say like this. All right, so move to back. I don't even know if you guys have a back to this. So you might have to just like move to a separate sheet of paper or some blank space. I know that there's blank space at the back of your packet, which you might not even have yet while you're watching this. Hopefully you do. So you can move to, just say like for your notes, like where you're moving. So I'm going to move on to the back. So for the back, so I've got vertical tangents at, what do I have, like radical 2, negative 1, negative radical 2, negative 1. But I'm also going to have more. Okay, so because I've also got to plug in positive, right? Because I had positive 1. Yeah, I also have positive 1 as a y coordinate. Yep. Okay, if y equals positive 1, then we've got, so I'm plugging in positive 1, so I'll have x squared plus 1 minus 3. X squared plus 1 minus 3 equals 4. So we'll get x squared minus 2 equals 4. Then we'll get x squared equals 6. So we'll get this. So vertical tangents at these and radical 6 positive 1 and negative radical 6 positive 1. Oh my gosh. So we've got 4 points. This has to be a crazy graph. So we've got 1 point. So on this original graph, we can't even get y by itself. So we really don't know how to graph it. But we know that it's a crazy graph because it's got just this one horizontal tangent at this point. But then it has 4 vertical tangents located at these points. Yeah. All right, guys, I'll talk to you soon. Bye-bye.